Today, let's look at advanced arrow pushing. Today's video is not about complex arrow pushing examples, but that some problems are easier done backwards than forwards. To better solidify, let's look at some examples. The first example is this reaction over here, which is about ICl3 plus Cl minus produces ICl4 minus. Arrow pushing in this example is easier when you start from the product. So the product is ICl4 minus. So our first step is to make the Lewis structure of ICl4 minus. ICl4 minus has 36 valence electrons, and when we make the Lewis structure, we get something like this. So that's the Lewis structure of ICl4 minus. Now we have to focus on the reactants, or what we are producing from this reaction. Well, when we go from products to reactants, we are forming ICl3 and Cl minus. When you closely look at the reactants, you can see that there are only 3 Cl or 3 chlorines rather than 4 which are present in the product. So that tells us that one ICl bond is broken and the Cl becomes Cl minus. So the question tells us that ICl3 is forming. So we break one ICl bond, and the other thing that tells us that we break ICl bond is the formation of Cl minus. So we break the ICl bond, and what happens is Cl becomes Cl minus. So the two electrons that are used to form a bond becomes lone pair, and the Cl isolates from the overall or from the actual molecule into Cl minus. So we get something like this, Cl minus and of course ICl3. So the reaction literally tells us what we are forming. So that was the first example. The second example is a bit more tricky than the first one because we have to draw an imaginary line that is drawn over here in brown to separate both of the borons. We are separating the borons because that's the only way we can form BF3 molecules. Okay, so in this example, we are following the same process we did in the first example, which is starting from the products and moving our way to the reactants. So B2F6 is the only product being formed, and our first step is to always draw the Lewis structure. So B2F6 has 48 valence electrons, and when we form the Lewis structure, we get something like this. Now when you actually look at the Lewis structure, you can see that fluorine has a positive formal charge, which is not good, but that's the best Lewis structure. Okay, now when we actually look at the reactants formed, we can see that each of the borons are only attached to 3 fluorines. So that tells us that some of the boron and fluorine bonds have to be broken in the products in order to get to the reactants. Now, this is one way of breaking boron and fluorine bonds. There are other ways of breaking bonds, but I think this is the easiest way. Now remember that fluorine is highly electronegative, meaning it will love to take electrons, especially when it's positive. So the bonds will be broken, and fluorine will take the electrons, forming the lone pair. Once these bonds are broken, we get something like this, which is boron attached to 3 fluorines, and it's a planar structure, and it makes sense because it only has 3 things around it. Again, boron is one of the exceptions that don't follow the octet, so it only has 3 bonds around it rather than typical 4. So that's all for today. Thank you for watching.